Hi girls, this is a video for 10.9 modeling with trig functions, and I've taken just a little bit of time before we started to graph a simple sine theta and cos theta. I should put this here, and I suppose equal to y to be precise. And for both of these functions, something that we all already know is that they kind of go up to 1 and down to -1, up to 1, down to negative. So that's what they stay in between. Okay? So if I was going to ask you what the maximum and minimum values were for these two functions, I would definitely say they never go above 1, so that must be the maximum value. And when I say what is the maximum value, I mean the y value. That's what that always means. They go up to 1 or down to -1. That's the max and the min. Now sometimes we get functions that have a lot more going on, so it might be something like this. Sorry. Okay, and that's a theta in there. Bad writing, I'll just put an x. Okay, and so, like that. And so I might say, okay, well, that part is always between 1 and -1. Just that part. I could see it right there. It's always between 1 and -1. So when I look at the maximum, I might say, okay, let's see. It's 2 times 1, because that's the biggest that can be, minus 8, which is -6. So that's the maximum value. And the minimum value is 2 times the smallest that can be is -1. And so that's -10. That's the minimum value. So I can use this 1 and -1 even when the function's kind of hard. Okay? All right, let's keep going. Here we go. Example number 1 says the temperature T degrees Celsius during the day in April is given by this crazy equation, okay? And in fact, there's a negative in front of this sign, so it's even flipped over the x-axis, where T is the time in hours after midnight. The little t is the time in hours after midnight. So it says, what is the temperature at midnight? Okay, so I'm going to start right there and say, T is the temperature, this, and this says the number of hours after midnight. So midnight must be T equals 0, because T is the number of hours after midnight. So I'm going to put T equals 0 in there, and I'm going to get big T, or the temperature, is 17 minus 4 times the sine of that is 0. All right, I think I put an extra bracket in there, but that's okay. And sine of 0, and I'm going to roll through these pretty quickly today because I'm in the video, but the sine of 0 is 0. So this gives me 17 minus 4 times 0, which is 17. I'll say 17 degrees Celsius. Okay. B says, what was the minimum temperature during the day, and what time did it occur? So that's a little bit harder. Okay, my min and max is the -1, +1 idea. Yeah? That's my min and max idea. I don't know how it's going to work exactly, but I'm going to write the equation out and let it help me determine which is the min and the max. Okay, now my claim to you was that this part of the equation, and it's really this whole part, that part, is always the maximum or minimum is 1 or -1, okay? This one's a bit tricky because there's a negative sign there. Okay, that's why it's a little bit tricky. So I'm going to just try. I'm going to make this whole thing 1 and see if I get a maximum. They're asking for a minimum. Let's see what we get. I'm going to put a 1 there, and I'm going to go, okay, that's 17 minus 4 times 1. The whole yellow thing is 1. So that's 13. And then I'm going to try it with -1. Shoot, sorry. The whole yellow thing. Okay, so when I put the 1 in, the 1, and this is when I put the -1 in, when I put the 1 in, I got the smallest value, the minimum temperature. So I found it. So it says, what was the minimum temperature? I got it. Minimum is 13 degrees Celsius. It's got to be one of these two. Then it says, at what time of day did it occur? So now I got to find that t. Well, the yellow is giving me the biggest hint in the world. The yellow is saying, okay, I'll find the t for you. I'm going to take that yellow. I'll put it over here. I don't want to use all my paper at once. And I'll go, I need the sine of pi on 12 times t to be 1. That's what it says. That's what I want it to be. I go, okay, well, let's see. Pi on 12t, I'm using my equation knowledge. Sine is 1 at one place, right up here. Yeah, on the unit circle, this is 0, 1. It's the only place it's 1, and that's pi on 2. So I'm going to go t equals pi on 2 divided by pi on 12. So I'll do a little keep change flip here. Pi on 2 times 12 on pi. This is lovely. It's 6. Okay, so I'll go, let's see. T is the time in hours after midnight. So I go, therefore, minimum at t equals 6 hours. So 6 a.m. That's 6 hours after midnight. Okay, cool. Now it says, over what interval did the temperature vary in the day? Can I just skip that for 1 second? Okay, because that's a weird question to me. The next thing I'm going to do is graph and state the period, because I think that will help. Okay, I'm going to do t from 0 to 24. I'm going to move up a little bit, so you're going to have to use your sheet. But I'm going to go, the minimum was 13, so I'm only using up here. So I'm going to go down to 24, and I'm just going to break this up like I usually do. Cut it in half, cut it in half. I can see that's where the min was. Cut it in half. Okay, I just added 6 to 12 to get 18. And I know that the minimum was 13. This is big T, this is little t. The minimum was 13, and the maximum was 21. I also know from here, right, that equilibrium, even though it's written out here, it's just written backwards. Okay, is the D, it's the equilibrium. Is 17 right in between here? Yes, it's 4 from each, and I could see how I did that. So I'm just going to put my dashed equilibrium in there, because that kind of becomes my x-axis now. That's 17. And then I'm going to do what I know. I know that this thing went down to a minimum here, right? And I know at 0, it was 17. And I'm just guessing, you know, wow, if it's a sine curve, it's definitely going to take the role that sine always does, and it's going to look like this. So it's really lovely. Okay, now let's go back to that question C. So it said, over what interval did the temperature vary on that day? I think what they're saying is, over what interval here, how did the temperature vary? So it varied between 13 and 21 degrees. I guess I could have done that from here, from this max and min. I don't know. It was confusing to me. So between, whoops, 13 and 21. That's how it varied. Much like cans, I would say, on a winter's day. Okay, and then it says, if the temperature was below K degrees for 2.4 hours, obtain the value of K. Oh my God. Okay. Well, first of all, it says the temperature was below K degrees for 2.4 hours. I don't think K is up here, because that means the temperature would have been low at for 6 hours, more than 12 hours. So it definitely is some K on here, K degrees, so that when I draw this in, this time right here, this time is 2.4 hours. Okay? How do I know where to draw it? Well, I do know this. I know that this interval here, from here to here, has to be 2.4 hours. Right? It has to be 2.4 hours from here to here. So I guess I'm going to go 1.2 this way, 1.2 this way, half of that, and 1.2 that way. So if I do 1.2 that way, I'll be 8.4. And if I do 1.2 this way, I think I get 4.8. Is that right? Oh, 4.6. shall I calculator it? 6 minus 1.4. 6 minus 1.2, I was right in the beginning, 1.2 is 4.8. I think I had it right in the beginning. So 4.8 and 6 plus 1.2, 7.2. I made an error that I guess some of you would make in adding 2.4 here and taking it there. No, I have to do half because that whole interval has to be 2.4 hours. Okay, I'm going to stop now because I reckon my video is getting really long. But what you need to do for this is to solve the equation using your calculator where I get that point. So I'm solving the equation 17 minus 4 sine pi on 12t equals 4.8. And I need to do that with a calculator. I need to subtract that 17, divide by the -4, and then I need to do shift sign. So I'm going to get a decimal answer. I'm not going to get an exact answer. I'm going to get a decimal answer. Try that out. We'll talk about it when I get back.